Hello, happy Quadratics Day 8. We're going to start off today by having you do a little warm-up. So if you'd pause the video and actually do questions 1 and 2 in the box. So I've asked you to look at the graph at the right, identify the vertex. So remember that vertex is that turning point. When I want you to identify it or name it, that means tell me the location. It's right 1 and down 4. First number is the x, that's right 1, and down 4, we represent going 4 down with that negative. So the vertex is 1, -4. And the roots is another important vocabulary word, and that is where it crosses the x-axis. The roots, the zeros, the x-intercepts. What else can I think of? Solutions when we're using it to solve an equation. Those are the spots where it crosses the x-axis. So the first one is at -1, and the next one is at 3, because it's all about the x-coordinate. The y-coordinate would then be 0. So what is the vertex and the zeros of the following equations? So you may not know what this equation looks like. In fact, I don't expect you to at all. So I'm going to clear my calculator out. Second plus 7, 1, 2. I'm going to go to y equals and type in the equation that I'm given in A. So x squared plus 8x plus 7. Okay, look at the graph, make sure it is a parabola. And we can't see it on our window. We need to identify the vertex and the zeros. The vertex is that point there, the zeros are here. However, when I use my graphic calculator, you're only approximating by looking at it, but we can verify the exact points by looking at the table. The table is in blue, so we press second graph. On vertex, we saw that it was in the negatives. And remember that when we graph our parabola, if we can have the matches, the guy that's all by itself is going to be its vertex. So it looks like the vertex is at -4, -9. And the roots are when the y is 0. So in my table, I can see at -7, y is 0, and at -1, y is 0. So the two roots are -7 and -1, and the vertex is -4, -9. So now we're going to try it with the second equation. This looks a little bit different because it's not in standard form. It's actually in vertex form, which we'll talk about eventually. So I'm going to clear y1 out. X plus 3, close that parentheses, squared, minus 16. Let's look at the graph. The vertex is going to be somewhere again where x is negative, but it's going to be pretty low. And I can look and find the roots. Perhaps we can see that it's at -7 and 1, but we'll verify in the table. So I'll press second graph to find the vertex. I want to get everything to match up on either side, so that middle point that's by itself is the vertex. -3, -16, and the roots are when y is 0, at -7 and +1. Okay. All right, so roots are important vocabulary, zeros are important vocabulary, x-intercepts are important vocabulary. All of that means where they cross the x-axis. That is when y is 0, okay? So I want to know what the roots are to this particular parabola. We have done several different methods so far to find roots. We've done them by looking at the graph and using the table. We've used the zero product rule, and we have used the square root method. So we're going to continue to do those. Honestly, when they don't give you a direction, you can do any of these methods. So for instance, for this one, if I wanted to do graphing, I could type in y equals x squared minus 144, and then find the roots, which I have to tell you, they're going to be a little bit tricky in this one. They're going to be outside this window. So the window, we'd have to either change our x and y, or you can press zoom out, and then you'll be able to see the parabola. And then we could use our table to identify when y is 0. So at -12. I'm going back down, and y is 0 at positive 12. So the two roots for this one are going to be negative 12 and 12. That's a graphing method. The second method we did is the zero product rule. So this one, if I can set two factors whose product is 0, I know one of the factors needs to be equal to 0. I notice that this is DOPS. So this is x plus 12 and x minus 12. So the first factor, what's going to make that 0? That's negative 12. And the second factor, what's going to make that 0? Positive 12. So you have x equals negative 12 and 12. So that was the second method. Okay, so we could graph it. We could use zero product rule, or we can use the square root method, which I noticed for this one, it's not a perfect square. So let's go ahead and use the square root method for this one. So if we're going to use the square root method, it should be x squared equals a number. So x squared equals 125. Using the square root method, we take the square root of both sides. But remember, it's plus or minus whatever the square root of that number is. I'm going to go off to the side and break down radical 125 because unfortunately that's not a perfect square. We're going to think of all the perfect squares. And then we're going to think of the largest factor, the largest perfect square that is a factor of 125. And 125 would be after 121, but it looks like the largest factor would be 25. Because 5 times 25 would be 125. Square root of 25 is 5. So radical 125 reduces to 5 radical 5. If you want to write them like this, just so we recognize that there are actually two, that's fine too. Okay, for C and D, I'm going to continue with the square root method just because I did write that's more of my focus today. But I wanted you to see for this one, you could do graphing, you could do factoring and setting up the zero product rule if that works, unless I tell you a specific way. But for the rest of them, I'm going to use square root method. So when I take the square root of both sides, plus or minus the square root of 18. Now let's break down 18, the largest perfect square. Yes, 9 times 2. So that becomes 3 radical 2. So x equals the positive value of 3 radical 2 or the negative value of 3 radical 2. If you want to write them out separately, you can. Okay, for D, I'm going to use the square root method. Take the square root of both sides. So x minus 2 equals plus or minus the square root of 36. I gave you a nice answer here because square root of 36 is a perfect square. So this is x minus 2 equals plus or minus 6. So at this point, I don't have x alone. So I actually have two equations in here. I don't have two answers that are plus or minus 6. I have two equations. I either have x minus 2 equals positive 6 or I have x minus 2 equals negative 6. Plus 2. So the left side would be x equals 8, or I have negative 4. So my two solutions, my two roots, my two zeros, my two x-intercepts are negative 4 and 8 for this one. Okay. Might be helpful to rewrite your perfect squares if you don't know them yet or aren't recognizing them yet. Write them out again. Okay, so find the roots of those equations. Let's use the square root method. So again, we're taking the square root of both sides. X minus 2 equals plus or minus radical 6. I can't break down radical 6. So since I can't break down radical 6, I just need to think about this as two separate equations. Okay, x minus 2 equals positive radical 6 and x minus 2 equals negative radical 6. And then we talked about this before, but I prefer to put the number first and then the square root part second, just so you don't think it's underneath the radical. And this tends to be the way most mathematicians do it. So x equals 2 minus square root of 6. If you want to put them together, since they are very similar, and the only difference is the plus or minus, you can write it as x equals 2 plus or minus radical 6. Okay, for B, it's not quite set up for square root method. First, we need to add the 64. So x plus 4 squared equals positive 64. Now it's set up for the square root method. Square root of both sides. X plus 4 equals plus or minus square root of 64. Square root of 64 is 8. This is going to be a nice one. So either I have x plus 4 equals 8, or I have x plus 4 equals negative 8. And I really encourage you, even if you think you could skip some of the steps, that you show me at least these two steps. So x can be 4, and x can be negative 12. These are the spots where that parabola would cross the x-axis. Let me just make that connection back for you. So if I were to type in y equals x plus 4 squared minus 64, okay, if I were to type that in, I'm going to look at the graph. Oh, I had my different window, which is actually not a bad thing because it's just a little bit bigger. But that right there where it crosses is at negative 12 and positive 4. Okay, so that's one other way I could have done it, by graphing, but by using the square root method, we're going to get those same two answers. Okay, C, add 12. So I have x plus 2 squared equals 12. Square root of both sides. X plus 2 equals plus or minus square root of 12. Let's break down square root of 12. 4 times 3 will work. Again, I went through here thinking of the largest factor that's a largest perfect square that's a factor of 12, and it ended up being 4. So I'm going to simplify that to x plus 2 equals plus or minus 2 radical 3, because radical 12 is the same as 2 radical 3. Okay, so now we're going to subtract 2 from both sides. So we'll write negative 2 plus or minus 2 radical 3. This, if you want to write it out separately like this, you can do that as well. Okay, D. First, it's not set up yet until I have just the x minus 2 squared. Okay, so take the square root of both sides. X minus 2 equals plus or minus the square root of 18. Simplify that, which I think we just did on the front. Simplifies to 3 radical 2. So x minus 2 equals plus or minus 3 radical 2. Now I jumped here to write this as a plus or minus. I'm going to show you how to do it separately if you want to. So you can write x minus 2 equals positive 3 radical 2, or x minus 2 equals negative 3 radical 2. So I'll have 2 plus 3 radical 2. And I'll have 2 minus 3 radical 2. Okay, so you can either write them separate or like that. All right, so now the last two questions, for example 3, are we just have to do a little bit more work to make sure we're set up to the square root method. Notice that I do have whatever I have squared over here, whether it's an x squared or an x minus 2 squared, but that 2 is in the way. So if you end up having a coefficient of 2, I want to undo that operation of the multiplication. So in order to get rid of this 2 from this side, if I divide both sides by 2, I now no longer have that coefficient or that factor of 2 in the front. So now I'm set up just like I was above. In fact, that's the same question as above now, to take the square root of both sides. 6 cannot break down. So the two answers are 2 plus or minus radical 6. Okay, for B, this last thing you could do is if there's a little bit more involved here, you may have to move the number over first. So 128 to both sides. So 2 times x plus 4 squared equals 128. Again, we're trying to get it ready to be set up for having just something squared by itself, whether it's an x minus 2, an x plus 3, whatever it may be, or just something squared. So I really don't want that 2 in front. To move that 2 to the other side, if I divide both sides by 2, because whatever you do to one side, you have to do the other, I get x plus 4 equals 64. Take the square root of both sides. X plus 4 equals plus or minus the square root of 64, and the square root of 64 is 8. And notice I actually have this from up here as well. But I have x plus 4 equals 8, and x plus 4 equals negative 8, minus 4, so x equals 4, and minus 4, so x equals negative 12. So my two answers are negative 12 and 4. A little bit neater writing if you want to see it on the posted on Google Classroom as well. All right, so now it's time for you to practice. Pause the video and try questions 1, 2, and 3, and then I'll post the solutions for those. Okay, so when you're done checking those, you can check your answers. And again, just so you're aware, today is Thursday. Tomorrow we'll have one more day of notes about quadratics. Monday is the review day. Tuesday is check-in with your teacher day. Make sure you don't have any questions. And then Wednesday will be our test on this quadratics. So if you have questions, make sure you email your teacher. After you have tried this practice, just so you're aware, for tonight's homework, I'm asking you to use the square root method. So I'd actually like you to use the square root method for most of these. Honestly, for A, if you choose to factor, I'm okay with that. But for the rest of these, you need to get x minus 2 squared by itself, or x plus 2 squared by itself before you take the square root of both sides. On the back, you're going to need to divide by 2. You're going to need to add 4 and then divide by 2. And then these questions are more of the way the Regents typically ask a question regarding this topic. They want to know what's the first step. They want to know what's the next step. What's the next step? And this one's what's a mistake regarding that. Okay, so if you have questions, email your teacher, and I hope you have a great day.